Hi, everyone, and thanks for joining us again here. Introduction to Data Science, Day 2. Sorry for running a bit late yesterday. On that note, I'm going to be more efficient about my announcements today. So I just have a few quick things to talk about. One is that next week, Monday is Labor Day. And so we will be running from Tuesday to Friday instead of Monday to Thursday. It'll be the same besides 5 to 8 p.m. Pacific, but we will be running Tuesday to Friday out of observation of the holiday. Now, of course, as I have already mentioned many times, everything is recorded too. But just to let you know, that is the schedule for next week. Also, thank you all for your patience. We've officially fixed the stand-up form. Yay. I'll drop the link to it again one more time directly. Please fill that out for what you did yesterday. You can wait till the end of the lecture to do that, so you pay attention through the lecture, but fill that out for what you did yesterday so we have it in our system. You should select Intro to Python as what did you study, and all of our other topics should be there for our remaining days. You should put the URL to the Colab notebook in the URL field, and you should make sure you set the permissions on your Colab notebook so anybody with the URL can see it. That way we can check out your work. And you should submit this even if you're not done, that's okay. It just lets us know that you're working on it. The actual due date is November 1st. All right. And then the last thing I just want to acknowledge is, yes, the first homework is hard. That's okay. When you get through it, you're in a good place for the program. That's the point of it. That's why we call this pre-course work. Once you are able to finish everything in that notebook, and the other notebooks will be given you, you will really be prepared. And we want to make sure our students are prepared, and we want to give them the support so they succeed. So as I just said, it's not due right away. And it's the sort of thing where if you have to take some time, you have to look things up, you have to ask some questions, you have to try some code, get weird error messages, try some different code. That is part of the learning process. And that is part of working in this field in general. That is not something to run away from. That is something to embrace in moderation. Take breaks too. But keep at it, and please, if you feel frustrated, just take a breather and then revisit it. At Lambda School, we're about reducing the barriers, right? That's why we're remote. That's why we're no money up front. And so if there's anything we can do to provide you better help or support so you succeed with this, please let us know. And on that note, I'm going to pass it to our Ryan here, and take it away.
Awesome. I am one of the Ryans. We have at least two in the data science class, myself and Ryan Herr. There's a couple other Ryans on Lambda School staff, so it gets fun with all the different Ryans around. But I'm super excited to be lecturing with you guys today. A couple of things that I wanted to talk about, just kind of to add on to what Aaron said, is I wanted to reiterate what we call at Lambda School the 20-minute rule, that if you are stuck on any portion of the assignment for longer than 20 minutes, you've been Googling, you've been researching everything you can to figure something out, and you're just stuck, you don't know what to write next, then at that point, feel free to reach out to a staff member. Data science staff members either have the red Lambda symbol next to their name, or they have a blue check mark next to their name. Anyone in the channel that you see that has one of those, you can send a direct message to, or you can do the @ sign in their name, to call them out, to ask questions where everybody else can hear. If you have questions during the lecture today, I will most likely see them better in the Data Science August 27 channel than I will here in the Zoom Q&A. I will try and look at the Zoom Q&A every once in a while, but if I'm sharing my screen, that chat doesn't come up very well. So it's better if you can ask questions in the Slack channel. The other thing is, if you are working on the videos asynchronously, like Aaron said, you have until November 1st to work on things. So don't worry too much about keeping up with the pace of the class every single night necessarily. Like Aaron said, the assignments are hard, so just do what you have to do to get them done. Ask for help, and we'll guide you through it. Show your grit and tenacity. That's really what we're looking for, which is why we don't spell out every step of every assignment for you guys. So, all right. But let's get started with today's content. Today we're going to talk about data wrangling. We're going to do some data exploration stuff, and we're going to use a specific Python library called Pandas. It's very, very popular data management library that's accessible to us. If you have any experience with R, it's borrowed a lot of its ideas from R and the data frames that exist in R, and we'll get into that a little bit more. I'm going to go ahead and share my screen here and be able to hopefully demonstrate some techniques for you guys. Make sure I share the right one. All right. Can everybody see that okay? Is the font size good?
I can definitely see it. I think the size is pretty good. But if others need more zoom, speak up or chat up.
Yeah, absolutely. Excellent. Okay, so here's what we're going to do. The first thing I want to show you guys is that basically Google Colabs, we've talked about this yesterday, is just a form of Jupyter Notebook that's on the cloud. It's in Google Drive, right? And so here's my Google Drive account, and I can make a new notebook by here clicking the new button. And it's kind of hidden, you know, because it's not one of the typical Google Drive files, but here to collaboratory, I can use that to make a new Google Colab notebook whenever I want. Kind of takes it a minute to cook up a new, you know, instance for me. But if you guys ever need a fresh start, that's something you can do to go and kind of get a clean slate with a new working notebook like this. What we will typically do in class is we will give you an assignment to a notebook like this that already has instructions in it. The best way to get started with the assignment is to go to File and save a copy in Drive. If you try and work in it right now, you probably only have view permissions. You don't have read and write permissions. So make sure you make a copy of it to your own account before you start working on things. And it's that copy that you want to submit in the stand-up form. So just some housekeeping things. But that leads into our first topic, is that a lot of data science and a lot of data analysis is done through IPython notebooks, or Jupyter notebooks as they're called. Now, these notebooks are very similar. They all follow kind of the REPL, read, evaluate, print loop that Aaron talked about with us yesterday. But there's other tools out there like Anaconda Navigator. Microsoft has what they call Azure notebooks. There's Kaggle has their own version of notebooks called kernels, and they all operate in basically the same way, and they're all more or less interoperable. You can copy your code from one to another, or get a file that you can import into the other one and have all of your data there. But I wanted to emphasize how important these are in data analysis. So let me find a link here. Jupyter, a company that has invented the Jupyter Notebook. When you'll hear lots of terminology associated around these notebooks. You'll hear IPython Notebook, which is kind of the original, and then Jupyter Notebook is supposed to be the language agnostic version of this REPL style format. They do exist for other languages, but we're obviously only going to focus on Python. But they're very popular in being able to share your analysis in a way that's reproducible to other people, which is something that we need a lot more of in data science. We need a lot more code and work sharing, and being able to view other people's work and learn from it. So I'm going to paste this link into the Slack chat here. Go ahead and take a look at some of these just to get the idea of the breadth and the scope of the things you can do with this tool. But you'll see as you look at some of these, here's notebooks in other languages. You'll see that a lot of these notebooks import other people's libraries, import other Python libraries to be able to do, not have to do everything in raw Python code. And that's something that's very, very common in data science. I actually want to show you, I don't have the link open. I've got some things on a couple of different screens here. Let's see if I can find it. Well, I'll get to it later on. So get an idea for how important Jupyter Notebooks are. It's a very common tool that we'll be using. But let's dive into this notebook that I made here, and let's let's import some libraries and let's, learn what we can do with Pandas in particular, which is the library, the main library that we'll be using today. We'll also be using a little bit of matplotlib to make some scatter plots and things like that. Let's get started. I don't want to go long today to make sure that everybody has plenty of time to work on the assignment, so I'm going to try and keep things managed. The first thing to understand is that in Python, there are different kinds of things you can import. There's modules, packages, and libraries. Now, a module is just a Python file with somebody else's Python functions that you can use. A package is bigger than that, and a library is kind of a collection of packages and modules dedicated to a specific purpose. So the biggest thing that you should know is that modules are small, packages are medium-sized, libraries are big. You'll hear those three terms used interchangeably, more or less. But we'll try and say library because that's most of what we're using with today. We're using the Pandas library, matplotlib library, but just know that those are generally the same thing. The way to get a library into your notebook is through what's called the import statement. Now, when I type import here, you'll see that it's highlighted in purple. In Python, that means that it's a reserved keyword. That means it has special functionality tied to it that will happen whenever I type it in. Others examples of these keywords is things like for and if and def, right? See how those all went purple on my text editor? Import is one of these special Python things. And so what we're going to do is we're going to talk about there's three different syntaxes you can use to import libraries. First is just the raw import statement. So we're going to import the math library. Might actually be a package. I think it's I don't know technically. But we're going to import math, and we're going to do some fun things with it. Well, relatively fun. You can always add text sections to your notebooks. And these follow markdown text. So this is text, right? And now you can add some documentation to your notebooks. But now that I've imported math, and you can see it has this little 1 on the left-hand side, that means that cell's been run. So I've got it in there. I've got everything that's inside of the math module here. So if I say, let's look at some of the documentation. Let's see some of the things that we can do with math. We're using Python 3, right? Yes, exactly, Troy. So because it's a reserved keyword, I should have mentioned this. You can't name a variable import because it's reserved by Python. That's what I was trying to get at. Exactly. So here's all the different things we can do with the math library. We can calculate sums. We can round something up to the nearest integer. We can take a factorial. We can round something down to the nearest integer. All kinds of things. We can find the remainder of two things: exponents, logarithms, powers, trigonometric functions, conversions between degrees and radians, all of our fun math things that one might want to do when using Python as a calculator. But I want to show you that if I create something like this long float, and I'm just going to, I don't know, give it a bunch of random numbers here. And if I round that up using the math module that I just imported and the ceil function, so the dot ceil raises up to the nearest integer and dot floor down to the nearest integer, and pass in and then print that out, you can see that that rounded it up to 1. And that's essentially how importing a library works. And I was able to access functions on that library using what's called dot notation right here. So it's used math dot ceil dot whatever the function name is that I want to access, just like they have tried to emphasize for us here in the documentation, right? So that's how we can import a library, get at its contents to do interesting things. Now, there's some debate about how interesting or not interesting that example was, but is more about how to import things than anything else. So there we can do other things. We can do exponents, 2 raised to the 3. This is the base, and this is the exponent. We're not going to go through all these math functions, but 2 raised to the 3rd is 8, right? Something that we got out of the box, didn't have to think about it very hard. Next, we're going to use a slightly different syntax. Now, I mentioned there's 3 ways of importing things. The next is called the import from syntax, and it goes something like this. If I only want the .ceil function from math, because it's a good practice to only import the things you're going to need to use so that your code is fast and efficient, I can say from math, give me just the .ceil function, or just some portion of the library or package that I'm interested in. Go ahead and run that. And, so because I imported math above, I already have ceil there. So what I'm going to do is I'm going to delete math. That's going to unimport it, so that when I re-import it with this new naming scheme, I'm only going to get ceil now, right? So if I run this function up here now, I should get an error because I deleted math. Does that make sense? Now if I work on it down here, math's not defined. Oh yeah, because I already deleted it. Comment that out. Okay, now we got a fresh start in this cell down here. Now if I use the same syntax I used above, let's use a different variable name here. And just to show you how .ceil always rounds up to the nearest integer. And I try and use the same syntax. I get an error, math is not defined. Because I didn't import math, I only imported ceil, right? Or the ceiling function. So if I delete that math dot, now it works successfully, right? So that's the second kind of syntax. From math, import just a part of it. And then the third syntax that I want to talk about with you guys with import statements is called aliasing. So in Python, often you'll be importing multiple libraries, doing different things with them, and you're not in control of how those libraries have created their naming conventions, right? So it might be the case that you include a math library that has a .pow function and some other library that also has a .pow function, right? You don't want those to conflict. So what we can do is we can give the portion of the library that we're importing a new name, kind of a namespace, if you will, to avoid variable collisions with other libraries. So what we're going to do is we're going to say import math as m. So this m can be anything I want. It's any variable name that I want. I could say bananas, right? And I could use bananas now. But we're just going to use like an abbreviated term. That's something that's very common, is you'll see an abbreviated form of the library name used right after it's imported. So that's one way of aliasing. I'm actually going to do another one here. We can combine the aliasing and the import from syntax to get a specific part of a library named a different way. So we do something like from math, import ceil as C, right? And I'm going to make sure that ceil's gone. And now we can use the same syntax that we used above, but just the ceil method or function that's been renamed to just the letter C. And I get 1 again. So those are the 3 different import conventions. Just import then the whole library, import from the library, import a portion of it, or from the library name, import a specific portion of it as something else, right? So this is something you'll see as we start to use the libraries that we're going to use today later on in our code, and it'll be something that's really important and something you'll be really familiar with if you keep on working in this kind of a Python environment. So let's move on to the pandas portion. We're going to pull in a real data set, and we're going to help clean it, help get it ready for kind of the state we would have it, and so we could load it into a machine learning model or something like that. But let's see. Before I move into that section, what questions do you guys have? Brian Benke says, yeah, and Aaron's on it there. In practice, if you use a package, is it practical to delete it after use if your program is large, or is the overhead of importing the package already realized? You will probably never delete something you've already imported. Just only import the parts you need, like Aaron said. That way you won't ever have to delete it. That was just so I wouldn't have conflicts and so that I could demonstrate the different portions for you guys. That DEL, delete library thing, is something you'll very rarely use. So mostly for demonstration purposes. So 3 very common Python libraries. Oh, are there any other questions? Okay, there are 3 very popular Python libraries: Pandas, Matplotlib, and NumPy, and there are 3 that we'll be using extensively throughout the intro course. I actually saw a funny tweet the other day. Let me see. I have it on my, on my website. I'm not trying to self-promote here. But I was going to make a blog post that showcased this, but it says, name a more iconic trio. I'll wait, right? Because it is very, very common, especially if you participate in Kaggle competitions or anything like that, to see very first line, import pandas as PD, aliasing it with that shorter name, import matplotlib.pyplot, so just the pyplot portion of matplotlib as PLT, import numpy as NP. So they're all aliasing these names of these libraries as they pull them in. And today we're just going to work with the very first one, and at the very end of the lecture, the second one as well. Okay, so let's go ahead and get that in there. So import pandas as PD. You'll almost always see it aliased or renamed as PD. I like to keep all my imports in a separate code cell from everything else. You may or may not want to do that, but for me, it's just a little bit cleaner in case sometimes your notebook can crash and you have to go re-import things. I just like to keep kind of a separation of concerns there. The first thing we're going to do with Pandas is we're going to import a data set, right? Now, there's multiple ways to do this. One thing is that I have put a couple of data sets on GitHub for us to use. And the easiest way to get at data sets that are in GitHub is to open CSV like this and then go to the raw version. You can see this raw CSV, and then I can just copy the URL. And we'll be introduced to our very first pandas function here. And I'll write out this line, and then I'll kind of explain what's going on here in a minute. And this URL needs to be in a string. So it needs to have single quotes or double quotes around it. So DF. DF stands for data frame, and that is the core pandas data structure that we'll be using. It's the way that all our data sets get organized. You can think of a data frame kind of like an Excel file, right? It's a grid. It has rows and columns, and each of the columns has a header, and usually there's some kind of an index, a unique index for each of the rows. Now, if you pull in a CSV that doesn't already have an index, Pandas will give you one, and it just goes 0, 1, 2, 3, 4 integers on the side as the index. But you can also assign it to have its own index. But let's get that in there. So we run that. Now, the way to view your data frame, now that I've imported it and saved it to this variable, is to use the .head function, which will, by default, display to us all the rows and columns of our data frame. Well, the first 5 rows of it. If I want more rows, I have to pass in an integer. If I want 20 rows, I can pass in 20. And I'll get 20 integers. Sorry, 20 rows of the data frame, the data set. but we're just going to go with 5 for now. And we can kind of get an idea of what's in this data set here. This is the famous Titanic data set, which is a very common starter toy data set for data scientists. If you haven't already done some kind of a tutorial using this data set, I am certain that you will. Many starter data science tutorials use this data set because it's a good mixture of lots of different things. We have text variables, we have numeric variables, we have floats, we have integers, we have categorical variables, we have continuous variables. There's lots of different kind of a smorgasbord of different elements to it that can help us demonstrate and learn different things. So that's what we're going to use for the demonstration today. It's that Titanic data set. But I want to show you one other thing. This is kind of a thing that's unique to Google Colab. If you need to get a local file into Colab, you have to import a Google Python library called files, and then run files.upload, and that'll allow you to open up a text a Finder window to browse and get the file that you need from your machine. But to spare you guys that headache, because of the kind of separation between Google Colab's living in Google Drive world and not being on your local machine, we're going to supply all of the dataset links as links to raw CSVs on GitHub. So a line similar to this should work out great for you guys on the assignment. So moving on, let's do some exploratory digging and figure out what's in this data set, right? So we've done the dot head. We can kind of scroll through and look at the different features. Now, I want to clarify some terminology. When I say feature, that's synonymous for column. Each column in the data set is a feature, and each row is an observation. So each row in this data set represents a man, woman, or child who was on the Titanic. It's kind of the ship's manifest. And each column is a different aspect of that person. So the survived column is whether or not they survived. The P class is, the class on the ship that they were on, their sex, their age, how many siblings they had, the fare that they paid, where they embarked from, on and on and on. And you'll see there's some rows here that are duplicates of other rows. Like the survived column is the same as the alive column. So there isn't a link to this notebook that I'm using currently on Learn.Lambda School. I will, after I demonstrate some things in this notebook, I will paste to you guys a different notebook that has a lot more detailed information. So if you're following along right now, open up your own notebook and take notes, because a lot of the syntax we'll be going over here will be useful on the assignment, but you will have the video to refer back to and a more in-depth notebook that has more instructions with it later on that I will share with you right as soon as the lecture ends. So don't worry about that. Just kind of follow along and focus on what we're doing. Awesome. Thanks, Joanne. So another thing that we can use is there's a lot of things on this DF, this data frame object, that we can look at. One thing is the shape of the data frame, and it's always rows by columns. So it's 891 rows and 16 columns. We can also this data frame object, in the software sense of the word, in the programming language sense of the word, has different methods on it. For example, like the described method, which will give us the summary statistics of all of the numerical columns in the data frame. Now, at this point, I want to stop and kind of reiterate, like, we haven't written code to do any of this cool stuff, right? We can do all this stuff in a single line and, 12 characters because we're importing an awesome library that's going to make our lives easier. Now, sometimes it's important to understand how the things you're importing work and some of the inner workings. So that's why it's important to always refer back to documentation. But you're going to notice that everyone uses these same libraries because they're so powerful, and they'll save you so much time in helping you prepare your data for further analysis, right? So the .describe method gives us all these important summary statistics: the mean, the min, the max, how many there are in each column, which is, you can see that age has 714. but the other rows have 891. Well, why is that? We're going to talk about that here in a minute, but you'll find out that the age column also actually has some missing values that we have to deal with in one way or another that we'll dive into here in a minute. So let's do that. Let's talk about cleaning the data. So I'm going to do a df.head here again. We're just going to look at the first 10 rows. And you notice that some of these, especially if you look at the dec column, you'll see lots of NaN. And that's an abbreviation for not a number. That's essentially Pandas saying, what? I don't know what this is. What's happened is this comes from whenever we import a CSV file that has blank cells. Anytime that Pandas, when it's importing it, sees a blank cell, it say, I don't know what to do with this. And it doesn't conform to the data type that is in this column, so I'll just say NaN. I don't know what it is. You deal with it, right? So this is a very common data cleanliness issue that you'll run into, and we're going to learn how to address it today. So the first thing that we're going to do is we're going to try and get a count for how many missing values there are in our data frame. Now, I'm going to stop right now because I'm not going to do this for you. I want you guys to use this as a practice of Googling. What would you Google to try and figure out how to figure out how many NaN values there are in a data frame? Go ahead and type in Slack what you would Google to try and get answers to this question. Pandas query NaN, okay. Pandas NaN. Good. We'll give you guys 30 more seconds. These are all good. I saw someone said Python 3. That's good. Okay, I'm going to show you what I would type. And it doesn't mean that anything you guys put is wrong. There's varying levels of Google query goodness, right? So I would say, what would you put, Aaron? Yeah, give us your answer. Oh, come on.
I was trying to come up with a name for the skill, Google foo. You know, I might take a scattershot approach to it, like 3 queries in succession, and then just see which one works.
Okay, that's a good idea. So I like to be insanely specific. So I would do something like how to count the number of NaN values in a Pandas data frame Python 3, right? Like, and it's ridiculous, right? That's a lot of typing. But I think you'll find that the more specific you can be with your query, the more specific answers you'll find. And sometimes I always like to throw in the name of the library I'm working with, and the programming language I'm working with, and the version of the programming language I'm working with, because sometimes you'll find a solution that's outdated, and that's one way to combat that. So there's my query. We're going to look for it. Oh, look, the first one's already highlighted. It's almost as if I clicked on it in preparing this lesson. Let's click on it again. Okay. So you'll get better and better at reading Stack Overflow questions and answers as time goes on. But the answer that we need to count the number of null values is right here. Now, I don't know what these lines do, so what I would do is I would come back and I would run just part of it. Let me go back. Is null, right? So we have to wait. There we go. And you would look up in the documentation and see that is null returns up to us a data frame, and that data frame takes every place where we see an NaN value and converts it to true, and every place where we don't and says false, right? And you would do that in the documentation. We don't have quite the amount of time to do that. Gil asks, is it unwise to copy and paste from code documentation? Not at all. I don't think it's wise to copy big chunks of code that you don't understand what they do. But I think it's very good to learn from others' code and learn from other Stack Overflow solutions and kind of see if you can dissect it and figure out why it's happening. If there's a function call that you see, find the documentation, learn what happens with it. Kind of do some experimentation like we're doing right now. Now, luckily, I already knew that the isNull function would return to us a data frame that would do all this fun stuff for us. But you would figure that out. You might have to dive into it a little bit. You might have to read a little bit, but you would figure it out. Exactly. Aaron's answer is perfect. It's a balance. You don't want to get too big. You don't want to get too crazy. You don't want to blindly copy and paste, right? And so somebody asked in the channel earlier today that they Googled and that's how they found questions and some answers on the assignment. They said, is that cheating? And it comes back to kind of the same question. It's like, do you understand what you're copying and pasting? Do you understand how the code that you're looking at works? Are you learning from the code as you Google and seeing other people's solutions? Or are you just finding a quick and dirty way to, get the right answer in, right? And it's kind of an honor system, but the world is open book and the world is open internet and open Google. So our assignments are also open internet and open Google because you'll find yourself Googling many a thing on the daily as a data scientist. So what we can do is now that we have that null values is we can use the .sum method which will count the number of null values in each column. So you'll see the age has 177 missing values, which we kind of clued into when we did our .describe up here and saw that there was not the same number of values in the age column as there were in the other columns. But you'll see this dec column is not numeric, it's categorical. So it didn't show up in the .describe call, but it does show up as we sum the null values. So, I mean, I've kind of done this in 2 steps here. I'm creating a null values data frame and then summing it up. You could also do it in one fell swoop and say df dot is null dot sum, and you'd get the same output here in one less line of code. That's called chaining when you add one function call onto the end of another. But that tells us we've got some cleaning to do in the age category and the dec category. So the next question is, well, how do we get rid of these NaN values? What should we put in? Now there's a technical term for what we're going to do next. It's sometimes called data imputation or inputting of data. So what happens is many machine learning algorithms can't work if there are blank values. They need numeric values and they need it for every observation. So we have a couple of options. We can either put in values that are somewhat sensible, or we can delete the rows or columns that have missing data. Now, there's a lot of considerations with both of those options. If, for example, the dec column has a lot of missing rows. So if we wanted to delete all of the rows that had at least one missing value in them, we would probably be left with something like 1/10 of the original data set. So that's not going to be an option. We can't just delete every row that has missing values. We've got to do something different. Well, luckily, Pandas has some built-in functions that will help us address this problem. But as you can see, we only have problems in the age and the dec columns. So I don't want to work with the whole data frame. I just want to work with one specific column of the data frame at a time. So I want to show you that there's 2 different forms of syntax for accessing a data frame column. The first is using dot syntax, df.age, right? It prints out all the ages. There's our NaN value. And the second one is using these square brackets and then the name of the column or the column header passed in as a string. So these 2 rows here are identical from runtime perspective. There's two different syntax, and they have slightly different use cases where you might choose to use one over the other that we're not going to get into today. Phil asked a really good question. The shortcut to comment out a line of code if you're on a Mac is Command ? Command \\. That's one that I like to use. You can select multiple lines, and but there are others as well. If you're on a Windows machine, there might be that may or may not work for you. It might be Control/ or something like that. But that'll save you a lot of time. But we need to be able to access specific columns in the data frame to clean out the missing values in just these columns. Yep, Control/ on Windows. Thank you. So I would let you Google again to find the function that will help us remove these null values, but I don't know if we have time for it. So I'm going to tell you it's just called fillNA. Let's find the documentation here. Reading documentation is a core skill of anyone working in code. And so while this might be Greek to you at first, over time you'll get more and more used to it. Now, the most important line, I think, in documentation is this line at the very top. It tells you the name of the function and also the possible arguments that could be passed in. These are often like different options if you need to customize the way that the function runs. Some are required and others are not. Also helpful as code examples at the bottom of the documentation to show you how things work. But I'm just going to show you two ways to deal with missing values. The first is we can impute the mean or the median, some kind of measure of center on a numeric column. And you ask like, well, isn't that like corrupting the data? Isn't that kind of ruining it? And you have to remember that whereas, researchers in an academic setting might need their data to be very pristine, we as data scientists or machine learning engineers or data engineers are more concerned about predictive power. Now, if I have a column that has two missing values, I could put gobbledygook in for those two missing values as long as it gets accepted. And probably being able to then use that column in my analysis, whereas I couldn't before, will probably lend me more value than what I would have lost by contaminating my data with those fake values, right? So whereas we can feel free to put anything we want in for those missing values, for example, the fillNA function that we've been looking at with Pandas, you'll notice they always have it equals df. And you can say here down, it says returns a filled data frame. That's very important to note because it's not going to make these changes in place. It's going to make changes to the data frame and then spit us back out a new data frame. Yeah, Brian's comment is spot on. The idea of imputing is to do what creates the least bias in the data, or to do something that's maybe a hair better than just putting in a random value, right? To do something that helps, if possible, put data in that's as close to what we think the original data might have been as possible, or that helps us get more predictive power when we run our algorithms. But so I'm going to do df.age.fillNA, and that's going to return to me a new data frame, and I'm going to call that new data frame called filled age. And if I just pass an integer to this, you will see, oops. Yeah, so we want to make a copy of our data frame first. Sorry. Let's just overwrite. Well, see, this is something I have to Google because I haven't memorized it. Data frame. What do you know? So intuitive. All right. Because I want to demonstrate you guys some things without messing up my original data frame. Name data frame not defined. Oh, that's because I called it df when you started. Okay. So now I'm looking at df copy and not my original data frame, right? So now if I'm going to overwrite in this df copy the age column with, you'll notice, well, let's actually not do the age column. Let's do the dec column because there's more NaN values here. It'll be easier for us to see the changes we've made. And I'm just going to put in a 0. Wow, that was really bad typing. And it needs to be an underscore. Okay, so you see the dec column has imputed values to it now. I don't know if that worked quite right. But if I want to just put in a 0 for the imputed values, it looks like that just changed it all to be counting up. But what we want to do is we really want to fill the age with the median of the age. So what we're going to do is we're going to make a new value called median age equals df. Let's stay with the copy dot median. So Hector says when you use df.copy.fillNA0, so if you do it on the whole data frame, it will fill all of the NA values in the entire data frame with the value that you pass in. If you do df.copy.dec, then it will do it for only that specific column. So this is something that can be, this is a function that can be run on the entire data frame, but you often want to just run it on a single column because you're going to want to use different methods for the different columns. And I need to speed up here a little bit to get done. This is the same thing Aaron was saying yesterday. So
an hour is too short.
We usually have at least 2-hour lectures in class, and so we're really having to slim things down here. With a break in between. It's not 2 straight hours, so don't freak out about that. But so I'm going to print out median age here. Median age is 28. Cool. Now I want to put that 28 in for the NA values in the age column, right? So I'm going to say df copy.age equals df copy.fillNA median age. And we'll look at the head again, see if that's been filled. I actually don't know if there is any NA values in the first 10 rows, but it's messed up this one too. Yeah, that's true. We do get the median in df.describe. So I could have come up here and, oh, we get the mean, 29.
I think the median is lurking there, right?
In
those quartiles.
50th percentile, that's right.
Yeah.
Perfect. And those quartiles could be useful in a whole bunch of different ways. You might think, why do they have those in there? But you don't have time for that. Okay. I'm going to delete this, and we're going to do it to the original. Now that we've seen the syntax. Okay. And now let's see. Here's our age class. Let's look at the first 20 values. And we'll see that row 5 has an NaN value. Okay. Df.age equals df.age.fill NA, or you turn this into a one-liner here, df.age.median. Whew. Lots of chaining. We'll see if this works right. Or if I just mess it up again. There we go. Line 5 has 28 in it now instead of an NaN value, okay? So that's if we just want to impute with a specific value, we pass it in. Now there's a second way of imputing that I want to show you, and this is the third to last thing we'll go over. It's called, we can either do what's called a forward fill or a backwards fill. What that means is if we have some kind of a categorical variable and we don't have a median or a mean value to go off of, we can just tell it to look for the closest cell that has an actual value and use that cell's value. So if we're doing a forward fill, it starts from the top and kind of copies those values down to the blank cells below it. If we're using a backwards fill, it goes up from the bottom and copies cells from cells below up to the blank cells above them, right? And that's something that we can do to the deck column. Yeah, let's do it. Now, you'll look in the documentation and you will see, oh, if I want to forward fill something, oh, this is the other documentation. That's the copy documentation. No wonder I'm not finding what I want. I have to pass in this method parameter along with it. And you'll see that forward fill is abbreviated ffill, backwards fill is abbreviated bfill. So trying to save us time by just cutting right to the chase, not making you dig in the documentation too much. And then, so right now we have NA values for the first, third, fourth, fifth. Let's see what we've got now that we fixed them. And I don't actually need to comment this out, but I'm going to anyway. Okay, so you see that it's forward filled, all the missing values. But you notice the very first one says NaN. Why did it not fix the first value of this column when we use the forward fill method to impute the values? Exactly. There's nothing above it that it can use to forward fill this value. So that's something you have to be careful with forward filling or backwards filling, is that it has to have something above it or else it can't replace the NaN value. But something else that I want to show you guys is that sometimes a column or a row is so problematic that we just don't want to deal with it right now. We just want to drop it from the data frame. And so we do that using df.drop, right? Now, what you have to do is, if you want to drop a specific row, you can pass in the row ID or the index, however your data frame is indexed. But we want to drop, let's just drop the deck column. Let's say we didn't want to worry about filling in, forward filling all these values. We just wanted to get rid of it completely. Well, we'll pass a string that is the column header. And because this is a column, normally we drop rows. It's more rare that we would drop columns. So this function has been written to automatically drop rows. If we want to drop columns, we have to pass a second parameter that says axis equals 1. So you normally see Pandas functions where it says axis equals 0 is a row operation, axis equals 1 is a column operation. And if we look in the documentation, we'll see that this function also returns to us a new data frame. But this time we're just going to override our original data frame with the dropped column data frame. And oh, it's because I tried to run it twice. Sorry. There's no attribute deck. Back it up. Okay. So it's because I just because I ran the cell twice, one time, the first time it deleted the dec row, and then I added more code and tried to run it again. And this is something that'll happen to you fairly often. And it goes, hey, there's no dec row, error. It's because I was just trying to run the cell a second time. But it did successfully do what we wanted to do. We no longer have a dec column in the data frame. That is an okay way to deal with unclean data. Maybe not the best way always, but as a data scientist, you're constantly kind of doing a cost-benefit analysis of what you're doing to your data set. Like, is the time that this is going to take me be worth it to the company, to shareholders, to stakeholders, for me to take the time to actually do that thing, right? And if you're rushed for time, dropping things might be a good way to go. So the very last thing I want to show you guys is a little bit of matplotlib, a very small part of matplotlib. Yesterday we had you guys doing some scatter plots, and today I'm going to do some scatter plots for you, because scatter plots are one of the very best tools for exploratory data analysis. And Burkall says, how did you know to use the median as opposed to the mean? Was there a skewness value in df.describe? That is a very good question. If there is more skew to the data, we would want to use the median over the mean. I didn't necessarily check for this. If we come back up to the df.describe, sorry, and then we'll get back to what I was saying, we'll notice that the mean and the median are fairly close to each other. And that lends me to think that there isn't a large amount of skewness. There are other things I can do to measure the amount of skewness in a data set specifically. But because they were so close together, I just grabbed one or the other. There wasn't really a lot of decision making there. And that's another thing I want to talk about is there's a lot of ways to go about these problems. One of the hardest things about data science is that things are so open-ended, right? You really have to think through your methodology and think about how are you going to defend your methodology to other members on your team, to executives. How are you going to convey to them why you did what you did and why what you did was a good or smart or valuable way to go about it, right? And so you'll get an experience with that in the assignment a little bit. We'll ask you to defend your methodology a little bit on one of the questions. But the very last thing I want to show you guys is that how to make a scatter plot in matplotlib, because it's such an important exploratory data analysis tool. So we're going to say import matplotlib.pyplot as plt. Did I spell something wrong? Matplotlib. Thank you. Aaron was this close. All right. So when you're using matplotlib, you every time you make a new graph, create a new plot, a new PLT, and you will set different attributes on that plot object using dot notation, and that's kind of how you go about telling it what you want. So we're going to create a scatter plot, and I would have you guys look at the documentation again, but I'm just going to give it to you because we have 2 minutes left. I use plt.scatter, and you're going to pass in your x values as the first argument and the y values as your second argument, and they have to be in some iterable object. That means a list, a pandas series, which is technically the data type of a column in pandas. So pandas is nice that we can just pass in directly one of the columns for the x values and another column for the y values, and it will plot those two against each other and give us a nice scatter plot. So what we're going to do is I'm going to particularly use the square bracket syntax on this one, even though I could use the dot syntax for accessing a specific column. We're going to plot the fair against the age, right? And if I run this right now, it will show the scatter plot because Jupyter notebooks are kind to us and often just display things even if we don't have the syntax exactly right. But you need to have plt.show on the end to really get that to display in all environments. And there's my scatter plot with the fair on the x-axis because I passed it in first. So it's x comma y and the age on the y-axis. One thing I also want to show is what if I wanted to label my axes, right? This is the very last thing we'll go over. Well, you would look in the documentation, you would find an example somewhere on Stack Overflow, and you would see that it's plt.xlabel, and then you pass in the string. Oh gosh. And same thing if you want to give a title to your graph. And it's important that you get in the habit of labeling your axes, labeling your titles, making your graphs as informative and useful as possible. So this is a great habit to get into. Age by fair, I think, right? Like maybe it's technically fair by age. I don't know. Okay, now we have labeled axes and a title on the graph. Whew, that was a lot. But I wanted to get you guys experience with some basic Pandas syntax so that you can dive into data sets now and do a little bit with them and get them ready for machine learning algorithms, do some data exploration. And you'll notice that a lot of things we went through here will be very, very helpful on the assignment. There are some extra stretch goals that we haven't delved into as specifically here today. But what questions are there about what I've demonstrated to you guys? Do we have to copy data frames whenever we make changes to a column per se? I think it is a safer practice to copy them so that you don't risk overriding your original data frame. And if you ever want to get back to the state it was before you made the changes, you're not really stuck. You just have to go back and run all the cells again to get back to where you were, which can be kind of annoying. As time goes on, you'll get more wise about when it makes sense to make a copy and when it doesn't. The safe way is to just always make a copy before you make a big change to your data frame. Otherwise, don't worry about it. But sometimes you get like 5 different copies in a notebook. You title them DF1, DF2, DF3, DF4, DF5, and you get mixed up. So as you get more experience, that'll become more intuitive. Abe says, sorry if I'm pronouncing your name wrong, but he says in Jupyter Notebooks, is there a shift tab functionality to learn about there is a shift tab functionality to learn about functions. Is there something similar in Colab? I'm not sure. Do you, Aaron, know if that exists?
So I'm not sure. You'd have to try it. I do know that if you put 2 question marks in front of something, you see its source code. Is that the sort of thing you're talking about?
And there's often also the help method you can use.
Yeah, I tend to throw things into help, or you can always use a search engine and find the full documentation.
Mohammed says, are there packages that we can import to make these charts and graphs look prettier? First thing you can do is to look at the documentation for matplotlib. There are lots of options to customize the look and feel of graphs, but there are whole libraries that tend to look better. There's a very similar library called Seaborn that I think just naturally has better looking graphs than matplotlib, and along with a few others. And they have a somewhat similar syntax, but matplotlib is the standard right now. So that's what we're working with today. Feel free to explore other ones. There's lots of really good visualization libraries that exist for Python. Is plt.show strictly optional for Colab notebooks? More or less, yes. If I take this off, it still shows fine. You'll notice how it kind of spit out a funny thing here. But get in the habit of running plt.show. at the end. It is your graph will still show, but it's more correct syntax to have it at the end. Okay, you guys have the assignment. You'll have the video that'll be uploaded to the syllabus website as soon as we get it uploaded to YouTube. And I will also soon share with you a collab with some notes in it that you can refer to maybe a little bit as you're doing the assignment. I might wait a little bit on that one because I don't want to make the assignment too easy on you guys. And if you have the video to reference back to, you should be able to see all of the syntax you need for the completing of today's assignment. So we're spoon feeding you a bit more than we typically do and more than we'd like to in the main class. But we are a little bit time constrained here. So that's what we're doing.
All right, great. Thank you. Keep asking questions. We'll answer them in Slack. But yeah, let's call it. So we're ending almost on time.
Almost.
That was tight, but thank you. Stay tuned for a few more announcements. In particular, please fill out the stand-up form for yesterday. We will drop the link for that again. Fill that out for yesterday. And then the plan tonight, now till 7 o'clock, work on the assignment, 7 to 8 o'clock, do the stand-up, meet with PMs, talk in groups, ask questions, get answers, receive more learning. So thank you, everybody. And it's great. And we got 6 more days of this, so keep coming back. Thanks, everybody.
Thanks, guys.